This video is going to explain to you how to calculate the average atomic mass of an isotope using percent abundances. You already know what an isotope is. We've already talked about them. An isotope is an atom that has the same number of protons but a different number of neutrons, like carbon-12 or carbon-14. And because they have different masses, you're going to notice that mass is different than on the periodic table, and that's because the masses on the periodic table are the weighted averages of all isotopes found in nature. And that is based upon their percent abundance. So how much or how often do they occur in nature? So we look at a weighted average, we're looking at not only a regular average, but we're also looking at how often it occurs as well. So it's sort of like we've taken the mode and the average and put them together. So the average atomic mass that you see on the periodic table, that's just the weighted average of the mass of isotopes in a naturally occurring sample of an element. So let's talk about how to solve these problems. And we are going to go through a few of these together. So this first example, we're going to talk about the steps of how to solve it. And then on the next page, we're going to start letting you slowly complete these problems on your own. So we'll do the first one together. The second one, you'll do a little more on your own. And then hopefully by the third one, you're feeling really good and able to do these completely on your own. And that's where this video will end. When you're done with the video, go ahead and work on the rest of the problems in this. So you've got up to 10 problems to do. Okay, let's talk about how to solve one of these problems. So each problem is going to give you some information. It'll probably tell you what the isotope is, the mass of that isotope, and these are an AMU, which you remember is atomic mass unit. And then it's going to give you a percent abundance. So just by looking at this, we can see that our most abundant one would be this zinc 64, and that's 48.89% abundance. That would be our most often occurring isotope, whereas this one on the bottom, zinc 70, at 0.62% would be our least often occurring isotope. So when we're looking at these problems, step one is that we're going to turn the percent abundance into a decimal by dividing it by 100. Of course, you also know that you can convert something into a decimal by just moving the decimal point 2 places to the left. That is the same thing as dividing it by 100. So if you want to just move the decimal point 2 places to the left, that's fine too. This number, once we do it, is going to be called our fractional abundance. So let's go through and find our percentages here, and let's convert them to decimals. So for our first one, we have 48.89, divide by 100 or move over twice, and you get 0.4889. The next one, 27.81, becomes 0.2781, and we'll keep going, 0.0411, 0.1857, and 0.0062. Okay, so step one is done. We have now converted all of our percentages into our decimal, which we call the fractional abundance instead of the percent abundance. The second and third step go together, and I have an equation to give you for it. You're going to take the fractional abundance that we just did and multiply it by the mass of this isotope, and we're going to do that for each one. So we'll take the mass times the fractional isotope, and then step 3 is we add up all of these together. So it kind of looks like this as an equation. So the equation is the average atomic mass is equal to, and then step 2, the mass times Fa, fractional abundance, and then step 3 is we add it to the next one, mass times fractional abundance. And you will have as many parentheses here as you have isotopes given. So for this problem, we're given 1, 2, 3, 4, 5 isotopes. So we're gonna have 5 of these parentheses. And that's what the little ellipses here at the end of it means, is that you're just gonna continue on for as many of the isotopes as you have. So for this one, we'll have 5. So let's work on setting those up. So for our first one, our first mass, 63.929, And we're gonna multiply that by our fractional abundance, 0.4889. And that's our first one done. So now we'll go to the second one. And there's our second one, and we'll just keep going. And that was our fifth one. So we can double check, and we have 1, 2, 3, 4, 5 sets of parentheses. And now what we need to do is put this into our calculator. So grab a calculator and let's type it in. Okay, so after you type all of that in your calculator will give you an answer close to 65. And you can double check that your calculations look exactly like this. And for our final answer, we're gonna write that number with a unit. And so we're gonna write our average atomic mass is 65 points, and we can just go out a couple decimal points, 39, and our unit is AMU, atomic mass unit. Step 4 is you should check this by a periodic table because your answer should match very, very closely to the average atomic mass on the periodic table. And if you take a look at the periodic table, zinc, number 30, it has a mass of 65.38. So we are very, very close, and that is a great answer for this question. Let's move on and try some of these problems together, but giving you an opportunity to become more fluent with them and try more of it on your own. So in this space up here, let's write down the equation that we're using, and it's the one that we wrote over here. The average atomic mass is equal to the mass times that fractional abundance. And don't forget the fractional abundance, all that we're doing for that is taking whatever the percent abundance is and changing it into a decimal. So let's look at number 1 together. It says find the average atomic mass of iodine. So we'll check our answer by iodine when we're done. If it consists of 80% iodine 127, 17% iodine 126, and 3% iodine 128. So let's go ahead and do step 1 where we take the percentages and turn them into decimals. So 80% becomes 0.80, 17% becomes 0.17, and 3% becomes 0.03. You can move the decimal point 2 places to the left or divide by 100. So watch very carefully because this time it's not listed out in a chart for us. We've got numbers together in a word problem. So this 80% is referring to 127, the 0.17 is referring to 126, and the 3% is referring to 128. So make sure you're really careful and keep those numbers together. So let's go ahead and set this problem up. So for our first set of parentheses, we'll take the first mass and multiply it by the first fractional abundance. So we've got the mass would be 127, because that is hyphen notation. And then our fractional abundance is 0.8. So our mass 127 times 0.80. And then we'll add it to the next one. And our next mass is 126. Multiply that by our fractional abundance, 0.17. And then we'll add it to our last one, mass 128, and fractional abundance 0.03. Then grab your calculator and put this into your calculator. Your calculator gives you an answer of 126.86, and we want to add the unit AMU. Next thing to do is check the periodic table and make sure our answer is correct. So if you look on the periodic table for iodine, it's number 53, it's a halogen, and the mass for iodine is 126.9, so we are very close. That is a great answer. For number 2, go ahead and try to set this one up on your own. So take a look at the percentages and turn them into your fractional abundance and match them up with the masses. Okay, so for this one, you were given that each of these isotopes of gold were at 50%. So each of them are 50%, which means This one is 0.50 and this one is 0.50. So when you fill out your equation, it should look like this. And then once you have your equation filled out, you can go ahead and input this to your calculator. Your calculator should be 197.5 as an answer, and we'll add AMU for our unit, atomic mass unit. Try number 3 completely on your own, and then when you're done, unpause the video and look at the final answer. So your final answer for this one should be 55.85 AMU. So to solve that, we notice that 15% becomes 0.15, and that goes with 55 as a mass of iron. And 85% fractional abundance would be 0.85, and this one goes with iron 56. So for a quick recap, you guys now know what a weighted average is, and you are able to look at the percent abundances for isotopes and figure out the weighted average atomic mass from them by converting the percent abundance into a fractional abundance and then multiplying that by the mass for each isotope and then adding all of those isotopes together.